Hey guys, how you doing today? This is part 2 of making circuit board on a CNC milling machine. Actually, it's a router, but I guess we're milling the board. Anyway, I'm going to get right into cutting the board because what I've been doing today is doing some test cuts. I originally planned to use this part 2 to show you some of the CAD stuff in Eagle, but since I'm doing testing, I'll go ahead and show you that too, and then when I know exactly what I'm doing and the adjustments need to be made in Eagle, I'll show you that. So things might be a little out of order, but I just want to get all the details in here and show you the failures as well as my successes. So let's get started with this part 2 in making circuit boards with a CNC router. Let's go. This is one of my very first cuts that I did, and I used a Dremel bit on this called a 105. It's actually their smallest bit that they make. Let's see if I can show this to you. It has a little milling ball on the end of it, and it's used for engraving. And this does a really nice job, but unfortunately it's too large. And this is the smallest that they make. Now on a bigger board that doesn't need close traces, this might work just fine. But you can see how I polarized some of the traces, but it does a nice clean job of cutting. Now the new bits that I just bought from China look like this. And they're a V-bit, 60 degree, and I'll show you some of the cutting from that. So this is my first attempt at using these 60 degree V-bits that I purchased from China. Not very good. It's more tearing the material than anything, and I can't run them as fast as I was running the other ones, these ones, the Dremels. So I had to slow it down to about half, and then I started getting good results. We'll get into that in a minute. I'll show you what happened when I slowed it down. But these V-bits do work, but you don't get the speeds out of them like you do the ball bits. Okay, so this is an example of my first successful try with the 60 degree V-bit. As I was saying, I had to slow my rates way down. I was running that ball mill about 10 inches a minute, and I had to slow it down to 5 inches a minute for the V-bit. So that is the secret to using the V-bit, is to slow the rate way down so you're not pulling the material and you're actually just cutting it. All these traces are good. I checked it with an ohms meter. I think I can improve it a little more with playing with some of the settings, but I think this will be quite successful. It's going down 7 thousandths. So I went ahead and drilled the holes in the first successful etch that I did and placed the components in, and you can see I've got some components that are pretty close together because of the way that this SD card reader is angled, the connections. I'm bumping into the amplifier slightly, so I went ahead and made a different version, and I turned these caps to the side. I moved the voltage regulator over, and the crystal I moved a little bit too. Moved the amp up so that the SD card reader would have more room. So we're going to go ahead and try that. Plus I've changed some other drilling settings and that sort of thing. So I'm going to go ahead and make another board and see what happens with this one. This is what the board looks like that I drilled, and works out pretty good. I had it set up so that the drill would go all the way through the board, and then I flipped it over. I didn't have it quite registered correctly, so when I drilled the other side, the holes didn't line up. Hopefully on this next shot though, they'll line up, and I'll tell you how I do that. Let me flip it over and I'll show you. So it looks kind of torn up on this side because you know, I already had holes going through, and then I slightly offset them when I re-drilled. So the trick really is not to put if you're going to drill twice on each side, or once rather on each side, I'm going to only go through a little over half of the board. So that's what I'm going to try next. Also, my speeds were up on this one a little bit, and I noticed those bits don't last very long. This side of the board doesn't look near as good as the other side, and I think it's just the nature of it. I could try to put a little bit of oil on the board as it cuts, but I really don't want the mess. I'm going to try to slow the feeds down and see if it improves. Looks a little fuzzy on this side. I know I can knock that down with a little bit of Scotch-Brite or something like that, but look at this side, and then I'll flip it over. You can see this side's much cleaner. Anyway, back at it. I wanted to review some of the things that I've been working on. The first thing that I did is I ran a program that leveled this table. Right here you can see, probably, hopefully, that I milled this entire table flat. And then after I got it as flat as I could, I took another piece of MDF. This is 3/4 inch. And I mounted it right here to where I can put my circuit board here. And then I put a stop right here. So the idea is to go ahead and push the boards into this stop, and then I can double side tape it. And I put a little notch here so that I'm able to clip onto it. And I'll show you once I mount a board up here. But this is the first step, is to make sure that you have a level table. And MDF is really the levelest material that I can think of to put on here. And that way when you're drilling and the drill passes through the board, you're just going into the spoil board, basically. Alright, so I'm going to give this another try, and I think I've got it to the point where I might actually get a good board this time. I'm going to go ahead and start it up in here somewhere. And the first step is to go ahead and tape this with double-sided tape. I've said this before in my other videos, but I like to use this blue stuff, and it costs more than regular cheap carpet tape, but it works a lot better. So invest in some good tape. So I'm going to use a couple pieces of tape on this. Make sure everything's clean under the board. You don't want anything raising it up. And then what I do is I just manually center it on here, and I'm pressing it against the stop, because that's the trick to flipping this thing. You need at least one square, so we're going to use this. So I'm pressing this way. Alright. Okay, so I'm going to use the drill first on the top, and I've got my probing software set up here. I'm going to go ahead and hook the grounding clip on the board, and that's what this notch is for. And the other goes to my router. I'll show you that. Let me raise this up. You can see this clip right here makes the connection. So I'm going to start out with my drill. I've got a .0295 drill that I've been using. And I've been using it for all the holes and the vias. Now this is a 1/4 inch cullet on my machine. And so I have to reduce that down to an 1/8 inch. And I'm using a 1/8 inch reducer that I got from Dremel. So when you chuck these bits in here, you want to put as much of the bit in that you can, because you don't want it, flapping in the breeze. The more length it has, the more whip it's going to have, more flex. So what I'm going to do is I'm taking my bit to the 0 reference point, and I'm just going to manually look for a place on the board that will work to start with. I'm going to start it right about there. See if I can get a better shot of this. This is going to be tough to film because it's so small. And that's about the best angle I can give you. Let's go with that. So I'm putting my bit really close to the copper. I've got it where I want 0 to start, right about there. So I'm going to go ahead and 0 my machine here. I'm hitting the reference all button, and I'm also zeroing the Z-axis. So I'm ready to start the code, and that's going to start the probing. Make sure you got your probe cables hooked up. You don't want any bit crashes. So this is the auto leveling happening now. It's pre-programmed with reference points, and it'll adjust the Z height according to the discrepancies in the board. Really like this software a lot. Alright, it's ready to go. Now before I start the code up, what I like to do is go ahead and turn the router on and manually just run the bit down into the corner where my 0, 0 is, because I'm going to use that for reference when I flip the board over. So I'm just going to run this manually down and put a hole all the way through it. I'm going to do that now. Okay, it went into a position of a tool change, and I wanted to go ahead and stop the router and tell you that I haven't figured out how to disregard tool changes yet. Some of the components, the different components have different hole recommendations, and the vias are different, that sort of thing. So there's about 4 or 5 different tool changes here. And I didn't want to go in and change the component hole size manually yet, because I'm looking for a global setting. I would like to use this bit for all my holes. And so what I do is when it asks for a tool change, I just hit next. I need to correct this problem so it disregards drill tool changes, but that's why I stopped, just to tell you. So let me go ahead and continue with the drilling program. Okay, so the front side of the drilling process is now complete. Let's take a look at it and see how clean it is. Okay, so there's the holes for the front side. They all look pretty clean. And there's my reference hole in the lower left there. So I'm going to go ahead and change my bit to the 60-degree V bit and begin etching in the front. Okay, so I'm going to go ahead and change my bit here for the V bit so I can start etching. And again, with the drill, I'm going to stick this in there as far as I can get it. without bottoming it out. The less hanging out, the less whip it'll have. Alright, so I've got my V-bit changed, and I've got it really close to the circuit board, just within probably an eighth of an inch. And we have to run the auto leveling program on the etch now and level this as well. Don't change the X and Y, just leave those alone. And we're going to go ahead and readjust for the Z now. I'm sorry I can't get a better camera shot. I've tried moving the camera around and it's really tough to get this. The circuit board reflects light too, so if I add more light, it just makes it glare. I think you've probably noticed when I turn the router on, it has a big glare. Anyway, this is the same procedure as the hole drilling, so as soon as it's done leveling, I'm going to go ahead and start the program. Alright, here we go. Well, I apologize for the quality of the video recording these cuts. I've got to work on getting a different kind of camera in here, or something that has a macro lens. I've cut a total of 3 passes for my settings, and I've been running a feed rate about 5 inches a minute for the type of cutter. It seems to work really well. Let me get my other camera out and I'll show you a macro of what we've got so far. Let me get this board up and then we'll flip it over. Well, that's what we have so far, and it's not as clean as what I started out with, like this one right here on the bottom. This blade has been used 3 times now, and I think these things just dull out really quick. But it looks like all the traces are good. That one looks a little suspect. And I adjusted the vias to be a bigger pad, and it looks like they have, but I think I could go up a little bit bigger. Anyway, I'm going to show you how I flip this board over. We're going to go to the other side and see how the holes line up. So I'm going to check the continuity of a couple of these traces just to make sure we're in good shape before I go any further. These real thin ones. This seems good. This one goes up to here. This one. That one's good. Not this one. So far it checks out. I'm going to go ahead and continue flipping this around now. This notch that I put in the board that I put my clip on also serves a good little handle. You can pull the board up from the tape. Alright, so I've got the tape on the other side now. Here's what we're going to be cutting. There's my reference hole. So I'm going to push this into the guide again, just center it roughly. Stick it down into place. I need to go ahead and change my bit out to the drill, so I'll do that next. Okay, I've got my bit in there, my drill bit. I'm going to go ahead and hook the ground clamp back up. And I'm going to go ahead and bring my, first I need to load my drill back G-code, so I'm going to do that. Okay, so I've got the bottom drill loaded. I'm going to go ahead and move it to that hole. That's roughly where I want it. Now I'm going to go ahead, I'm sitting about a 1/8 inch above the material. I'm going to go ahead and zero out my Z, and then I'm going to tell it to go home here. Okay, now if you notice, well, you probably can't see it, but I'll show you in just a minute. My hole's over here and it thinks home is over here. So what I have to do is just move this manually, not moving the Y, but just the X to the hole. So it's as perfect as I can get it to the hole. I think that's going to be it. So now I'm going to go ahead and zero out the X. So now that is my new zero coordinates, and hopefully everything will line up once I start this up. It's going to do the leveling feature first, so let's just go for it and see what happens. Alright, it's leveled out the board, so let's see what happens. Let's go ahead and drill it up. Alright, the drilling's done. The holes look very clean. I'm going to go ahead and mill this other side before I give you a close-up of it. I'm thinking that running a drill cycle on each side's better than going all the way through on one, so you don't get that poke out from the other side. These holes look really clean. I'm not sure they're lining up perfect yet, but we'll see that when I go to the close-up. I'm going to go ahead and change the bit, and then we'll start milling the back here, and then we'll be done. Well, as you can see, the cutting's complete. Let me go ahead and peel this up off here, and then we'll get a closer look at it with the macro. Alright, here's a close-up look at the board. I checked out the holes, and they're almost aligned perfectly. So that technique worked out pretty good about zeroing the X. This is the front of the board, and my traces seem a little bit small in certain spots, like right in here. They're still conductive, I checked it, but I'd like to see them a little bit thicker. And the via pads are a little bit small too. I need to check the settings on that. There's my reference hole there. Let's go and flip this over. And there's the side we just did, the back. It's not terribly rough. You know, I was complaining about the bits going dull quick. I think that's true, but I think next time I do one of these, I'm going to put a little bit of machine oil on the top of this and see how long a bit will last. Start with a new bit. So I'm pretty happy with that, but it's still not perfect. I don't know that I can get it perfect, but this is a usable board, but I want to continue to try again and see how good I can get it. So I'm going to go ahead and mount the components in here and play around with it and see if everything's fitting properly. Well, that's going to be it for today. I've got some really nice looking boards here that I want to sit down with and carefully analyze before I make my next move. What I like to do is document on a piece of paper everything that I'd like to improve, and then as I make the improvements, check it off. I'd mentioned my via traces were a little bit small, so I want to improve those. And I still have to work on the etching depth. I think I can come up a little. I'm cutting at 7 thousandths right now. I'm going to try 6 thousandths. I'm going to also try some machine oil on the board and see how that works as far as making the bits last longer. I'm looking with a flashlight through the board, and you probably can't see that on camera, but the holes are lining up quite well, so I like how it's registering. I did another earlier one here and it wasn't registering nearly as nice, but this one looks pretty good, so I think I have the registering down. Now I still have to do the outline for the cutout, and I haven't done that yet either. And plus I want to put a little logo on here. You know how you always see a little logo on the board. So these are some things I have to work out, and then when I get all this figured out, I'll show you the changes and what I did in Eagle. So basically I want to learn this part first before I speak about it. I think that's the safest thing to do, is get a good board and then talk about it. So meanwhile, I'm just going to record these videos like I did today and show you, my progress as I do it. Not meant to be a how-to video, but who knows, maybe you'll learn something in here. So thanks for watching. Don't forget to give us a thumbs up. If you have any ideas, ways I can make this better, let me know in the comments below. Thanks for watching. Thanks for all your continued support, all our new subscribers and old alike. We'll see you next time. Well, this is a look of a board that I cut off camera. I lessened my cut depth down to 6 thousandths instead of 7, and it made a tremendous difference. And then I cleaned it with a toothbrush and some alcohol. I've just got the components sitting in there. Let me take them out and I'll show you the board. I think it looks really good. Hang on. What do you think? This is the top of the board, and I also went through Eagle and changed the vias, and we'll go through that in the next video, how I did all the changes for this. I just wanted to show it off. Let me flip it over, it gets better. Well, there it is. There's the back, even with the custom etching of the Brew logo. Alright, I wanted to just show you that I'm getting along really good on this. I'm pretty happy with this. So in the next video, we'll go ahead and cover what I did in Eagle to make all this happen, and then we'll solder it up and test. That's it for now. Hey guys, this is Steve. Thanks for watching. Hey, don't forget to subscribe if you like this video, and be sure to rate and comment. See ya.